Hey friends, we are going to learn about the composition of functions, which I am 99% sure you already know. So I do love teaching you things you already know. So it says, consider the function f of x equals 2x minus 3, and it asks you to evaluate. Evaluate just means you're plugging in this value for the x's. This should not be new. And so then in doing so, you end up with 7. So you would say f of 5 equals 7. Here it wants you to plug in 5x minus 1. So you are going to put that in for this x. So whatever they give you goes in where the x used to be, even if it's, even if it's not just a number. And then you would do the math. So in this case, you would distribute the 2 and then simplify. So you would say, hey, the function when I plug in f of x, 5x minus 1 is going to simplify to be 10x minus 5. That's just kind of getting your brain in place. Sometimes in math, we input a value of x into a function and then use that output or the answer to plug into another function. Okay. So the output of the first function becomes the input of the second. And when you use the output of one as the input of the other, that is called composition. So this is kind of the gist of what we're doing. So if you have a function, if you think of them as kind of like little input outputs, if you put in an x to function 1, whatever it kicks out goes directly through another function, and then this will be your ultimate answer, whatever comes out at the end. So again, I think you've done this, so you'll see hopefully something that you recognize. This notation is a little weird, but it gets to look more like you're used to pretty quickly. So it's giving you a g of x. It's saying the value of g when you plug in a 2 is c, so find g of c. So what we've got to do is find g of 2 by putting a 2 in for the x. That becomes a 7. Since g of 2 is c, then 7 is c. So this is asking us to find the g value at 7, if that's your x. So I go back to the function and put a 7 where the x was, and I end up with 22. So you're running it through, like it said, the outcome of one becomes the input of another. So then for our notation, there's two ways that you can write it, and you want to make sure you understand both. They both mean the exact same thing. So if you see this writing in either of these two ways, these are the same. You would read them both f of g of x. And in both notations, the function g gets substituted into the function f. You're kind of working your way from the right to the left. This is also kind of a key concept to know, is that in general, they are not commutative, meaning plugging g into f does not give you the same result typically as plugging f into g. So those are some important concepts to kind of know moving forward. We are going to do a couple of examples in different styles. So when working with a composite, you first evaluate the inner or right function, and then use that output as the input for the outer or left. So you work your way from left to right. So maybe jot yourself a little note in plain language, work from right to left. And if they're written with parentheses, you're kind of working your way from the inside out. So they're giving us the two functions and telling us, that's terrible, what each one does. Here's function f, here's function g. And we are, in this case, finding f of g of x. So we are going to plug 3 into function g, which is 2x plus 1. So 2x plus 1, but we're replacing that x with a 3, will result in a 7. But then that 7 becomes the input for f, that outer layer. And so then function f, which is 3x minus 5, we put a 7 where the x was, and we end up with 16. So 16 is the answer to that function. So like this would be a 16. The 7 is not really the answer. It's sort of your middle, like the first output that becomes the second input. This is kind of asking us the exact same thing, but backwards. So we're both plugging into 3, but here we plugged it into G and then F. Here we're going to plug it into F and then G. And we are not going to get the same answer. So if I plug 3 into function F, where there used to be an X, I'm going to put that 3. That'll kick out a 4. That 4 is going to become the input for the next layer. And so then I look at function G, which takes 2 times your X plus 1. I'm putting a 4 in for my X, and my final outcome is 9. So this is an example of saying, hey, with F of G of 3 is not the same as G of F of 3. Plugging it into F first and then G does not give the same numeric result as plugging it into G first and then F. It can happen, but it's uncommon. This one's weird, but lots of things are weird, so we'll just do it. F of 2 means I'm going to plug 2 into function F, and that will give me 6 minus 5, which is just a 1. And all it's saying is, hey, so this is the same as this notation, F of 2. So I did that inner layer of F of 2. And since that turned out to be a 1, then I'm going to do the outer layer of F using this output from the first round as the input for the second. And so I'm going to use my same function. Oops. Got to use function F, which is 3 times my X value minus 5. Putting that 1 in there, my final outcome is a negative 2. And so that is my answer. Okay, here it's saying you might not have numbers. It's saying when working with compositions, input does not necessarily need to be a numeric value. We can also simplify and find the composition of 2 functions without evaluating a specific number. This is important to do because this you do get asked to do a lot, and you want to feel pretty confident about that. So here we have our 2 functions from before, and we are taking function G and plugging it into F. So we're going to put all of G of X in for any X's, or any and all, really, in the function F. So F of X takes 3 times whatever you're plugging in and subtracts 5. And what we're plugging in is G of X, which is 2X plus 1. And then you just need to simplify. So I would distribute the 3. And I would end up with F of G of X equals 6X minus 2 when it's all simplified. Here they're asking me to do the exact same thing because this notation means G of F of X. So I should say they're asking me to do the exact opposite thing. We're going to now take function F and put all of those, like the entire function, in for the X's. So here we're going to put all of F, that whole function, in for the X's of G of X. So G of F of X is going to take all of function F and put it in for the X in function G. So in here, I'm going to put in my 3X minus 5, and then I'm just going to math it. So I'm going to distribute this, get that from my distribution, and then so in the end, G of F of X is going to be 6X minus 9. And so again, you notice here that F of G of X did not come out to be G of F of X. It's not impossible, it's just unlikely. So it's not very common that that would happen. This is just kind of some more examples. Okay, so this is the last part. I would honestly prefer that you turn the video off and you try these and then you look to see if you're doing it correctly. They're giving us 3 functions to work with and asking us to just kind of mix it up. So this first one, I just do the interior layer first and take H of 4 So that will result in a 5. And then that becomes the input for K. So looking up here, that's going to be 5 squared plus 4 times 5 plus 5, because I'm putting that 5 in for all of the x's in function K up here. And so when I do that, I end up with 50, which you can confirm on your calculator. This is asking h of m of -2, so working my way from the inside out. I'm first going to plug in -2 to function m, which is 3 times whatever you're plugging in plus 2 according to the rule up here. So that's going to be -6 plus 2, so I end up getting a -4. That becomes then the input for my second layer, which is h, and h is 2 times whatever you're plugging in, -3. So I end up here with a -11 as my final answer. And then here, this is written the same as k of m of x. And here, I'm not plugging in a number, so I don't expect a number answer. If you plug in a number, you should get out a number. If you plug in an x, you should get out a function with x in it. And this one's sort of unpleasant, but it is definitely something you need to know how to do, because we're going to take this entire function, 3x plus 2, and put it in for this x and this one. So we will have 3x plus 2 squared plus 4, and then the 3x plus 2 goes in for the x right here, and then plus 5. So we actually have to FOIL this first one out, because keep in mind that this is the same as 3x plus 2 times itself, and this will absolutely happen to us. So I'm going to have to FOIL here, distribute the 4 here, and then ultimately combine like terms. So if I FOIL this first part, 9x squared, both the outside and the inside will be a plus 6x, so that'll turn into plus 12x. These guys are a plus 4. Here, distributing my 4, I get a 12x plus 8, and I have that 5 kind of chilling at the end. So when this gets cleaned up, I'm going to have just my 9x squared, 12x plus another 12x is going to be 24x, and then 4 plus 8 plus 5 is going to be plus 17. So not impossible, just kind of a lot of work, but certainly all doable and absolutely something you need to know how to do. All right, let's take a look at this, because this is going to start giving us the information in different ways. It's not hard, it's just different. So it says the figure shows the graph of the function f on its domain from 0 to 9, and the function g is given by this. So we have function f over here and function g in like actual function form. So the function h is going to be defined as g of f of x, and we're supposed to find h of 6, which means g of f of 6. So start with what we know. We're supposed to find f of 6 first. Well, this is function f. If you go to where x is 6, the y value is a 1. So f of 6, meaning what do you get when x is 6? You get a y value of 1. Means we then have to use that as the input for the next layer, which is g. So if we go back to do g of 1, we're going to have this and plug in a 1 everywhere there was an x. And I'm just taking the function from up above. And if you do that on your calculator, it should kick out 6.12. Here, there's 3 ways. They give you function f right here, which you'll find your outputs by looking up your inputs as xy pairs. Then here is function g, and this piecewise function h, and then k they describe. It says it's a quadratic function with a horizontal translation of 2 and a vertical translation of -3. So you have to remember what we've already learned about that and say that would mean k of x is going to be x minus 2 to give me the translation of 2, squared to give me a quadratic, and then minus 3 to give me the vertical translation of -3. So I'm finding my values of f from here, g from the table, h from the piecewise function, and k from this function I built based on the description. So in example 6, like this is a really good example of what you might see on the AP test because it mixes everything together. It's just basically saying, hey, use the information above. So in this first example, to do this, I have to find g of 7. That is using this table. So it's basically saying when x is 7, what is y? So g of 7 is going to be 4 from the table. Now it's saying, hey, using the graph, when x is 4 as your input, what is your y value? Well, here's 4, and my y value is -1. This guy is the same as g of f of 7. So I first have to find f of 7. And since that is a table value, I go to 7. I see that my output or y value is a 2. And then I'm going to need g of 2. That's off the table. And when you plug in a 2 there, you get out a 3. In C, I have h of k of 0. So I have to use, to find k of 0, I have to use the function that I built based on the description. That's going to turn into 4 minus 3, which is 1. So then h of 1 is going to be up here, keeping in mind that these are the x's and these are the outputs. Like these are the x's you input, and then these are the rules for finding your outcomes. And so in this case, it's telling you, hey, if x is 1, y is -4. So it's basically saying that, which is the same as saying f of 1 equals -4, sorry. So here, this is an h because they called it function h. H of 1 is going to be -4, which is actually what they're asking us in this question. Here, f of 8, I have to start with that. And on the table, the y value that's associated with an x value of 8 is 0. But then my next layer is also f. So now I'm looking up f of 0. And if I look back where x is 0 on my function, my y would be -3. This one is g of h of 1. So I start with h of 1. That is my piecewise function. And we already talked about the fact that h of 1 there is a -4. So I'll be finding g of -4. Well, g values are found on the table. So when x is -4, the outcome is apparently pi. So that is my answer there. And for this last guy, g of k of -1, I got to find k of -1 first. K requires me to use this function that we built based off the description. And that's going to turn into -3 squared, which is 9 minus 3, so 6. And then my next layer is g, so g of 6, that is the table again. And in the table, when the x is 6, my outcome is -2. So I really like that section because it makes you really get comfortable with how to find the values. That is absolutely something I can see you needing to know because it does put together a lot of concepts. Same with these last two. These are AP exam. I want you to highlight those in your notes for sure because that just means, hey, this is exactly what you're going to see. So the table gives the values for functions of f and g at selected values of x. Functions f and g are defined for all real numbers. Let h be blah, blah, blah. So that's a composite. So if they want us to find the value of h of 1, they want us to find the value of f of g of 1. So we have to start on the interior and find g of 1. So be careful. These are my x values. So here is the column where you put in an x value of 1. This is g of x. So when you put in a 1 for an x, you get out a y of 0. And then when you go to put that as the input for f, you now are putting in a 0 for x. And for function f, that would kick out a -1. And that is going to help you identify b as your answer. 100% you would need to know how to do this. The function f is given by f of x equals that, and g is given by this other thing. Which of the following is f of g of x? Okay, here we go again. F of g of x has not got a number, so I don't expect a number answer. So it's telling me that I have to take this guy and put it in for all of the x's over there. So I need to put it in here, square it, take away 3. So take away 3 from here, and then where this x is, I have to put in 3x plus 5 again, and then I have a plus 7 at the end. So 3x minus 5. Keeping in mind, squared means multiplied by yourself. I'm going to FOIL that bad boy and get 9x squared. Both the inside and the outside would be negative 15x, so together they'd be negative 30x. And then my last two terms, that'll be a positive 25. Here I need to distribute, so I'll have negative 9x. Here I'll have negative 15, and then a plus 7. Shoot, I'm sad. I copied wrong because I'm me. And I here have my 3x plus 5, but here I left it as a negative. So let's just try that foiling again, because it wasn't fun enough the first time. Not going to be significantly different. It's just going to turn into 9x squared plus 30x plus 25, and then I'm still going to have my minus 9x minus 15, and then my plus 7 kind of chilling at the end. So combining like terms, I have my 9x squared, I have a 30x, and then a minus 9x, so that's going to be 21x. And then I have a 25, a minus 15, and a 7. And so that turns into 17, and it's multiple choice. So I am just matching that, and I'm matching that to option B. So that is, I think, a pretty hefty mix of something you already know. I think this notating it with the graphs and the tables is different, and that's why I really want you to focus on making sure you know how to do that section, because then it doesn't look so much like Algebra 2. It's going to look more like what you might see on the AP test in our Super Smarty AP Pre-Calc. Thanks for watching, kids. Bye.